warm welcome once again. And it's my honor and privilege to be the moderator for this session. A very special one indeed, because when it comes to a technology conference, a panel, an exclusive CTO panel, really stands out. Don't you agree with me? So, gentlemen, thank you very much for sparing your time. And Mr. Petkar, Dr. Saravanan, really appreciate you taking time out and traveling down to Bangalore. And I guess, Sumeet, you have also traveled. You are based in Bangalore, right? So really appreciate you kind of taking your time out, managing your travel schedules. And in these days, the kind of journey that the automotive mobility industry, the transportation industry is going through, CTOs are busier than ever before, I'm sure. And in many cases, perhaps, they may be having an even busier schedule than CEOs maybe. So, and of course, not to mention the kind of role they have in terms of not only kind of helping their organizations navigating through the current technological challenges, but also, more importantly, to kind of design the technology roadmap for the future, which at this stage, there's no absolute clarity in some of the areas, so it makes the job even more challenging and exciting at the same time, I'm sure. So coming to the theme of this session, which is on, this session will focus purely on the powertrain technology, including EV powertrain. So we'll try and draw a picture. In fact, the esteemed panelists will help us see, kind of give us glimpses of the future of what the powertrain technology mix could be like over the next decade. Because this decade, as we all know, is going to see a lot of developments. I mean, to just name a few, from a time when we were talking about only diesel, gasoline or petrol and CNG, now we are talking about starting about alternate fuels like biofuels like ethanol, then moving to a greater mix of ethanol to flex fuel, and then the discussion on hydrogen. That discussion has been there for quite some time, but now it's taking a more serious tone and looks like the government is more committed now to make it a reality. That is hydrogen. So there's focus on green hydrogen. And of course, then there are others like, let's say, synthetic fuels or e-fuels, as some may call it. That is on the ICE, on the internal combustion side. But then there's a lot of development happening on the EV side also. As we all know, electric is going to be the future. But perhaps it's not so simple as that. So to start off with, Mr. Petkar, if I may ask you to just crisply draw a picture for us in terms of what kind of evolution curve do you see for the internal combustion engine in the future, more specifically over the next decade?
So thank you, Sumantra, for having me here. Good morning, all of you. I think this is a very pertinent question, I must say, because I think the kind of overweightage that the EVs are getting these days, I think people seems to think that there is no life left as far as the ICE engines are concerned. But I think that is not the case. And if we look at the global projections in terms of the share of the ICE engines, it's going to be there. And what one looks at the data from the leading analyst, what is being said is that even by 2030, we will have a significant share of the ICE engines. Now, this is not to say that there is going to be a sort of a break as far as the EV revolution is concerned. So EVs will make the significant penetration, but of course it will have its own transition time. So coming back to this question about evolution of the ICE engines, I must say that the ICE engines have come a long way. Ever since their advent in late 18th century, I think they have come a long way. And if you look at in terms of uh, energy efficiency, I think it is one of the finest energy converters from the fuel energy to the mechanical power, and therefore it actually sits at the pinnacle of technology. And the IC engines have come to also become quite versatile in nature. They have become highly adaptable to the multi-fuel scenario, what you just now mentioned, starting with the diesel and the gasoline, to the blends and to the hydrogen. So in the last, let's say the 100 plus years, uh, the IC engines have significantly improved in terms of efficiency, in terms of the power density, in terms of durability, reliability, in terms of the noise, vibration, harshness, NVH, and also I would say in terms of the cost efficiency, they have been quite attractive as far as the value proposition to the customer is concerned. So coming back to what do we see from where we are today in the next, let's say, a decade or so, the IC engines will continue to get evolved. There are multiple reasons. Government is not going to stop investing into, let's say, the alternate fuels. In fact, we are seeing significant investment happening in the area of the biofuels, ethanol, the blends, also the CNG. The penetration of CNG is actually on rise. And even in the case of a diesel, we are looking at, let's say, the blend comprising of either it is with the ethanol or with the methanol, and the S2Is, which is emerging as a viable technology. So therefore, the IC engines will continue to get evolved till at a national level, we reach a target of net zero. And so therefore, I think for all the IC engine community, I think there are going to be clearly 4 to 5 focus areas. One is to look at how to improvise the efficiency of the IC engines from where they are today. So today, I think, depending on what fuel engine that you talk, I think clearly we can see an upside of at least 4 to 6% improvement that should be possible in the efficiency. Then the focus has to be to create the engine which is going to be fuel agnostic, which means it is able to reconfigure itself with large part of the engine to be common, but only the pertinent changes with respect to be able to operate with the multiple fuel options. So that's going to be a fuel agnostic approach as far as the engines, and so would be the case at a full vehicle level. The thirdly, the piece which is around, let's say, the modularity across the entire value chain. And the fourth is going to be about the achieving the emissions which are going to be absolutely near zero, even from the IC engine.
Okay.
And that is, I think we are on the course with the alternate fuel and in the near future about the H2Is. So the blame is not to the IC engines. I think it is about, the garbage in is garbage out. And actually, as I said before, the IC engines have come to become very versatile, and therefore they have been able to evolve themselves with these multiple fuel options being around there. So the future continues to be there, and till the net zero technologies become completely commercially affordable with the respective fuel and the charging infrastructure, I think the IC engines will continue, and surely, but they will taper down from where we are today. That's what we can envisage.
Right. Thank you. Thank you for sharing your thoughts. You know, what was also running in my mind is this: when it comes to discussion about the future or the life of or prospect of ICE engine in an era where it is increasingly electrified, it's similar to it. To me, it appears like a similar discussion similar to in the engineering field, when softwareization is on the rise, everyone is pursuing software engineering. Does that mean that the mechanical engineering will cease to exist, or will be less or no important any longer? But perhaps not. So it's a similar story there as well, it looks like. Dr. Saravanan, hydrogen is gaining more and more attention. And if this year's Auto Expo is an indication, I mean, there were occasions earlier also when OEMs, including Ashok Leyland, had showcased hydrogen technology. But this was the first time where both majors, Tata Motors, Ashok Leyland, and showcased the H2 ICE technology. So in the overall powertrain mix, what level of maturity has this technology achieved, and what role will it play to kind of, if you look at it, even enhancing the life of the ICE technology?
Good morning. Thanks for the opportunity for me to be on the dais. Fantastic gathering here. First of all, on a lighter note, if anybody is looking for to walk away with the final decision on what the powertrain will be, you're in the wrong place. The more you hear from us, the more confused you will be. That's the reality of what's happening. Coming back to the context of, I think, first of all, must thank Mr. Petkar for such eloquently discussing the advantages of IC engine, which makes me very happy to say at least there is one more large ally who believes in IC engines. I think coming back to the topic of hydrogen, I mean, the challenge for any alternate fuel, unlike diesel, is that from an OEM perspective, it's not just saying, I'll have technology ready. It's about the infrastructure. I think it's true for every alternate fuel. Talk about CNG, LNG, even EVs, fuel cells, hydrogenized. It all boils down to having the right combination. So it's a chicken and egg game to say when it will be ready and so on. On the hydrogen ICE, luckily I think hydrogen ICE has certain attributes that at least on paper seems to make it a real viable option in medium to large commercial vehicles. When I say that, I'll tell you why I mean medium to large commercial vehicles.
A low-hanging fruit, if you like.
I mean, I wouldn't say low-hanging yet, but I think there is potential opportunity that way. A reason being, I think if you look at Indian perspective, it's not just about net zero. I also believe a lot of the push from the government comes from the fact that they want to have energy independence. And the fact that we have potential to produce large amount of green hydrogen, given that we have large areas of wind power and solar possibilities, green hydrogen is a good possibility. So it makes sense for us to say, if we produce green hydrogen in abundance, what makes the mobility sector? There are two options, fuel cells and hydrogen ICE. And given that we have a large ecosystem of hydrogen ICE ecosystem in India, both from OEM perspective, it makes sense to say, can we explore that? And that is where you see, even though people argue that the efficiency of a hydrogen ICE is lower than fuel cell and so on, I do believe given the overall factors, which is the ecosystem of hydrogen ICE, it is much easier probably to implement in the current ecosystem. It makes sense from a customer perspective used to IC engines than a fuel cell. It has certain advantages over EV, but of course some challenges also. A lot of the OEMs are looking at hydrogen ICE. There are challenges of dealing with hydrogen, including embrittlement in terms of mechanical parts, including safety factors both in handling in the vehicle, outside the vehicle, and so on and so forth. Those, I think, will be solved. So do we believe hydrogen ICE could be a potential? One of the puzzles one of the pieces of the puzzle. We're not saying it will be the complete picture. The reason I say is as we go up and up to larger GVW vehicles, the potential combinations explode. You can potentially argue that LNG is an option, hydrogen ICE is an option, hydrogen fuel cell is an option, maybe EV is an option. So I think the challenge for us is to say, how do we explore these opportunities, particularly hydrogen-based, and then come with the right solution. So I think it's not an easy answer. Hydrogen ICE, yes, is it maturing? Not yet. Everybody's working on it. When it will come, maybe in the next 3 to 4 years, you'll start seeing some volumes of hydrogen. Again, that dependent on the infra availability and so on. The first applications you will see is probably in areas where there's a limited vehicle movement going on. For example, large ports possibly, or it could be large customers who have a captive fleet that will work with the OEMs to implement them. Yeah. So not an easy answer, but yes, it's a possibility. That's all I could say.
And of course, good to see that at least you have started seeding out the test vehicles with your collaboration with Reliance recently. And by the way, very, very quickly, what are the initial observations of that test?
No, I think I would say seeding is a strong word. I think it's a first set of proof of concepts. As I said, a lot of challenges to be solved. The initial set of feedback is, I would say, encouraging, I would say. But I think I would say it's at least 2-3 years away in terms of maturity of technology itself.
Right. Okay, thank you. And Sumeet, you are the representative of not only Electra EV, but the EV industry in this panel. So in terms of the powertrain evolution, because of course there's no question about fuels and all that, but it's more about, if I look at the equivalent, it's about the technologies, maybe better technologies, no? Lithium ion, what next, metal layer and things like that. So how do you see though it's still at a nascent stage, but a lot of technology efforts are being made at the labs. So, and in fact, if I'm not wrong, the first non-lithium battery technology is expected to be commercialized starting this year with Finergy and the IOCL JV. So that would be the first instance of a metal layer technology in the Indian market. So how do you see this EV powertrain technology evolving? And at Electra, how do you plan to progress?
Yeah, first of all, thank you for having me on the session today. A pleasure to be amongst this august company of ETAuto and all the esteemed guests and the panelists. Coming to your question, I think before I answer that, picking up on the point that got made by Rajendra and my colleague from Ashok Leyland, I think they're both right in their sense. This technology of ICE is not going to go away so easily. Obviously, there has been more than 200 years of development and technology that has come to a level wherein it's so reliable that we don't have to worry about putting a key in the car and worry about whether something wrong would happen or somebody would get stranded on the highway or freeway or of anything of that kind. So that's certainly going to be there. Now, yes, there are norms that are being implemented all over the world by all the governments because of our combined initiatives to reduce the carbon footprint. These things are certainly going to catapult or speeden up the adoption of our green mobility in the best possible way. And the pace at which the development happened for ICE engine technology per se, I think the pace for developing the e-mobility would be much faster because we're really seeing the pitfalls of having these carbon emissions go out. You can see the global warming is one of the biggest examples of why we need to go there much faster. So speaking of that, whilst and keeping it in context of the topic of the discussion today, whilst we will certainly see people moving away from the likes of diesel, going to even stringent emission norms by the day, there's certainly going to be an evolution before we completely go to hydrogen, which is green hydrogen. There's going to be gray hydrogen or even blue hydrogen, which is going to be in the place. And as my panelist over here said, the ease of converting a traditional ICE engine into a mobility machine which can utilize these fuels, alternative fuels, or even hydrogen to that matter, is going to be a low-hanging fruit for people before they converge completely onto the EV bandwagon. And the biggest reasons why this mass adoption of EVs is not going to be very easy is because of the triad, the typical triad of technology, cost, infrastructure, which when sorted out will lead to a cascade of mass adoption. And speaking of the technology, now coming back to your question, I was just picking up on the thread so that we stay in context. Now coming back to your question, I think the advances in EVs are going to happen in multiple ways. If you speak of first, before I go to the likes of the batteries, if you speak of the likes of the semiconductors, which is also the other part of the EV revolution that is going to hit us, most of the semiconductors today are still kind of relying heavily on the IGBT technology, which is silicon-based, but has been there for a while. There has been scale established on this technology, because of which it's low cost and it's reliable, but the problem is it's not very efficient. Therefore, what's going to happen, the changes that you're going to see in the times to come on the semiconductors front, with a lot of investments going in the material science, all the good work that is happening, is that you'll see a lot of these silicon carbides taking over, a lot of these gallium nitrides taking over. They're also, semiconductors based on silicon, but of a different variety. Now, the advantages of moving in this direction of semiconductors is that it will lead you to a huge advantage in terms of efficiencies. IGBTs, if they're not able to give you a huge amount of efficiency, what eventually ends up happening is that because of the loss of efficiencies, the weights that you have to increase in these semiconductors to reduce the heat losses, or to make it work even after expending all of these heats, is that you end up losing the advantage of making the vehicles light. I mean, you can't make the vehicles light, and then you'll need a bigger battery to get those bigger ranges, right? So this shift of going from IGBTs to gallium nitrides or silicon carbides is going to be a huge push in increasing the efficiencies of semiconductors to such a way that there's going to be a reduction in the weight, reduction in the sizes, and the so-called range anxiety is going to get away.
Great.
Right, and one last point coming on to the batteries that you had said. All chemistries, you mentioned about sodium ion, you mentioned about aluminum air, all the good work that Finergy is doing. We are going to see that, but yet again, keep the triad in your mind. Technology, cost, and the kind of infrastructure that you build around it, with keeping in mind the efficiencies that they're able to drive. And in India, an Indian customer is a classic case of finding the best jugaad. We heard of jugaad early on in the day. We heard of jugaad yesterday. But Indian customer finds the right fit for his application. And if it works for him, which means if the scale is enough to give him the low cost, best efficiency product, he will latch onto it. So that's how the evolution of this technology is going to happen in the times to come.
Thanks. And very interesting perspective that you brought in about on the semiconductor part also in the context of today's discussion. That's another interesting space to watch out for. Praveen, you represent a very important part of this whole pie, because you represent a technology partner. So, in the increasingly disruptive era, suppliers of any kind, be it software technology or hardware, is even more crucial. It's more of a co-creator, a co-collaborator with the OEMs. So just draw a picture for us crisply in terms of how is the role evolving rather, when it comes to kind of partnering or supporting OEMs and helping them to come up to develop new powertrain technologies, and what is being expected from you more, and how are you kind of proactively, what kind of approach are you taking, which is perhaps a departure or maybe different from what it has been so far?
Thank you. Firstly, I take this opportunity to thank you all for having me on this panel, and an interesting topic on powertrain trends also. Coming to the suppliers, right? The question is about how the supplier collaboration is all about with the OEM in context of powertrain, right? Today, for decades and years, OEM has always depended a lot on supplier ecosystem, because there is always a trust on supplier with their competence, expertise, and that's what this relationship between the OEM and supplier has been kept very strong. But also the dynamics are changing from what it was earlier. from a mere component supplier, how the suppliers used to supply to the OEM ecosystem, they are changing into an integrated system suppliers, right? So there's something like a partnership model which is evolving, because there is a heavy reliance on supplier ecosystem, because they come with some deep expertise in their domains, and OEM always relies on that kind of expertise to contribute into the vehicle development process. So that being said, today there are many companies, be it Bosch, Continental, Delphi, Cummins, okay? They are playing a vital role in many vehicle development programs with OEMs such as Tata Motors, Ashok Leyland, Mahindras of the world. And the expectation from OEM also is that they be a turnkey, okay? When they say a turnkey, the entire integrated system they deliver, okay? And also participate in innovation programs along with the OEM for the upcoming trends, and also participate in the integration testing to make the vehicles successful, actually. So that's the clear demand that the OEMs would lay out in front of the supplier ecosystem. And also, we have seen the business model also evolving of late, where even a risk-sharing partnership is being discussed about, where OEMs may not come forward to make an investment in the development with the supplier, rather a risk-sharing partnership where the OEM is tasking supplier, when the vehicles get sold, okay, they get their share of business, actually. So this way, they are becoming more and more integral, and expectation is also very, very high, given the expertise that they have, and given the kind of synergy that they are also showing with the OEM, actually. I think this is going to stay, and this is going to evolve further going forward. And today, we have even seen the changes, the way that they both operate together. Earlier, it used to be little silos for various reasons because of technology evolution itself. But of late, technology is such that it is removing that barrier in the collaboration, engineering collaboration between OEM and supplier. They're all on the same platform. They can collaborate, innovate jointly, engage in virtual twin concepts, and evolve the vehicle quickly, okay, to introduce into the market, actually.
So the spirit of collaboration, the practice of collaboration is on the rise, right? And just staying with you, as a supplier or provider of digital or software technologies, when it comes to this context in the context of today's discussion, because time to market is becoming increasingly crucial, and product cycles are shrinking in the market, so therefore time to market is even more crucial. So to what extent are you able to kind of enhance your support in terms of reducing the time of design, development, testing, validation programs?
Yeah, so traditionally, the time has always been a challenge, even in the past as well as now, right? Okay. It was never at comfort, because any OEM would want to introduce the vehicle, capitalize on the market. And now with the advent of so many new technologies coming in, like hybrid, electric vehicle, hydrogen mobility, and even with a lot of norms that are getting evolved, like what was discussed about emission norms, there's a lot of emphasis. Even when the Euro 6 or Bharat 6 norms were laid, there was huge pressure on OEM, okay, to ensure that the introduction of this technology at first time right, actually. Okay, there's always an essence. And this requires lot of simulation studies to be performed, because not everything can be done in real world, in physical world, because that's expensive. At the same time, it is time taking, actually. To even build a prototype, run it for a couple of months or years, it takes lot of time and efforts and money. And that's where the simulation technology plays vital role. And with these new dynamics in the trend, okay, new technology on the powertrain front, it's not that the simulation applications would just be used as is. New workflows have to be developed, actually, because it calls for newer ways of defining the workflows, engaging in calibration, engaging in simulation studies. It's a process by itself. Okay, and there definitely the virtual twin that I spoke of, it is definitely reducing the time taken to.
To what extent, and can it be shrunk further?
Please repeat.
To what extent has it been reduced, and can it be shrunk further?
Say for example, we can even look at reduction close to about 40%, 50% in the time, okay, based on these simulation studies. And even our colleague Rajendra Petkar said, right, garbage in and garbage out. Okay. Even for simulation studies, the right data inputs need to be given so that you can get the best out of simulation studies, iterate multiple scenarios, ensure that the vehicle or the system that you're introducing is performing to the right level of expectation, right level of quality standards actually. I think multiple ways, even if I take powertrain itself, especially electric vehicle or hybrid or even hydrogen mobility, there's a lot of virtual simulations even for battery chemistry, okay? Even for thermal simulations actually,
right,
or ensuring the right level of performance actually. And even vehicle dynamics, because this new introduction of the varied powertrain technologies also bring in a lot of changes in the drivability conditions.
Have a bearing on the overall braking dynamics.
So this is where I think simulation plays a vital role.
Great, thanks. We are nearing the end of this session, but before that, I would like to get your viewpoints, Mr. Petkar, and followed by Dr. Saravanan. You know, when it comes to automobile majors, in this case, in your respective organizations, how do you devise a technology roadmap in this context of powertrain technology roadmap, where not only is the age becoming increasingly disruptive, there is no absolute clarity in terms of which road to take or because the road itself is like getting built as we move, and also with the backdrop of increasing focus on sustainability and carbon neutrality.
Yeah, so good question again. I think in the interest of time, I would be very brief here. I think there are two overarching parameters as far as Tata Motors is concerned when we have to look at to devise the strategy for the powertrain. Number one, what is the target for the net zero? So at a country level, it is 2070.
2070.
At an individual organization level, you know, different companies have different targets. But
for Tata commercial vehicle 2045 and passenger vehicle 40.
Yeah, so Tata Motor commercial vehicle 2045 and the passenger vehicle 2040. So that is one parameter, which is overarching parameter. The second overarching parameter is the science-based target initiative, SBTI. And SBTI, so it is not enough just to say or make a declaration that by 2045 we are going to be net zero. It is actually important that how you are going to reach, and therefore what steps you are going to take, and how are you actually going to commit year on year the improvement that you would do in terms of the GHG emissions. And today it is voluntary, and as a Tata Motor we have signed up for that consortium of the SBTI, and therefore we have a plan to actually improvise the GHG footprint year on year, and therefore that dictates the powertrain mix. So these are the two overarching. Beside that, the technology on the IC engine side, for example, gets very tightly coupled with the fuel roadmap from the government. So we may wish to do many things, but of course, like what Mr. Saravanan said some time back, that there has to be the fuel availability, right? The hydrogen we can do, but the fuel has to be there. So I think fuel roadmap from the government, regulatory roadmap, and what is going to be the preference of the consumers. And we have seen sort of even the new young generation wanting to own the EV if it is affordable, right? So these are the multiple factors that we keep in mind, triangulate all of them, and then decide the strategy, as far as the powertrains are concerned.
I'm sure, I mean, it's well explained, but when it comes to, the things are not as simple as they seem to be, but it's quite complex, but best wishes to you all on not to be able to devise the successful, sustainable technology roadmap.
Just to say one more thing at the end, there's always this cycle of plan, do, check, act. Plan, do,
Plan,
check.
look,
In our engineering philosophies, we say plan, do, check, PDCA, which means if you plan something, do something, and then check. Calibrate yourself, act accordingly, and that's where you course correct yourself until you find the right strategy for your roadmap.
Dr. Saravanan, your thoughts on?
No, I think for us, the two keywords are, I would say, flexibility and agility. Gone are the days when we have a roadmap, it's a 5-year roadmap, it's static, we execute. Those days are gone, whether it is in engineering development or in strategy. So for us, what looking at is saying, what are the key drivers from a government perspective, externally, internal perspective, company's perspective. So strategy for us has been focused on the core strength, which is looking at alternate fuels has been a core strength. But I think definitely what we do is we have a roadmap, but we don't say it is static. It is fairly dynamic because the requirements are getting dynamic. Who would have thought that somebody would say, use methanol for IC engine, right? Unheard of. So I think for us, keyword is, I think this is probably true for most OEMs. How do we stay nimble? Look at, I mean, to be honest, we're learning new things. Typical product development cycles and the strategies would be very fixed. We would say, okay, we'll do the typical waterfall. We will get the product to a certain very, very good reliable levels and launch. Now we are talking about minimum viable products in automotive industry. To say, because there are so many options, how do we learn? We can only learn by launching a minimum viable product, at least in a pilot stage, so that we learn quickly, relearn and all that. So for us, strategy is now completely rethought in terms of how do we stay nimble, how do we have flexible roadmaps, how do we create partnerships so that we can execute this much better, how do we work not just from a technology partnership, ecosystem partnerships, supplier partnerships. I think it's all about partnerships, agility, flexibility. That's sort of how I can say our roadmap is going to be. And that's how it's going to be for the next 10, 15 years till we stabilize to maybe 2, 3 key technologies. So it's going to be chaotic, but I think enjoyable journey for all of us.
And enjoyable, chaotic journey to be indeed. Yes, we have run out of time, but since we also started a little late, wouldn't want to kind of not give the floor an opportunity to ask a question. We have time for exactly 2 questions. If you have any, kindly raise your hand, keep it brief. Who is it for? Can a mic reach the gentleman there? Can the mic reach the gentleman there? Yeah, quickly.
Hello everyone, I'm Tarun Kumar Thakur from Mercedes-Benz Research and Development India. The question I have is, what are your views on hydrogen combustion engine announced by Toyota in 2023? Is that a game changer? That is one question. The other question is...
Well, I wish we had a Toyota representative in the panel, but yeah, what's the second question, please?
It's, are EVs as clean as we think they are? So they utilize a lot of resources, lithium,
Okay.
and all of these resources, and what if they're fueled by thermal power?
Right, there's an EV standing right outside, which happens to be a Mercedes-Benz one. But Sumeet,
I can answer the second question first, and maybe then the panelists on the right can maybe try and answer the first question. I think if I have to answer the question straight, obviously today, the place where we are, EVs are not as green as they need to be. That's where the concept of green to green comes into picture. That's why the concept of green hydrogen. Otherwise, we would have even thought of using grey hydrogen, which, by the way, is a very good alternative to ICE engine today, moving to a greener solution with very good efficiency levels. Therefore, if I have to say it very, very clearly and cleanly, the transition from not so green to completely green and from a completely green solution to a green solution will take a while to get into effect.
one question from this. You have the, where there's mic in hand. Yes, please, quickly. Yeah, you can be a little loud. On hybridization. Yes, starting with you, Mr. Petkar, quickly on the hybridization prospects on maybe...
Yeah, I will just briefly say that, yes, we are not great lover of hybridization from my company point of view, because it's an intermediate technology, intermediate step, but of course it has a potential. It actually can deliver you better range. In the urban areas, it can have the zero emission because it will run on the pure battery. So therefore, you would see that there is a coexistence of the hybrids alongside with the conventional ICE, non-hybrid, and also the battery electric vehicles, which are actually clearly leading in terms of what they deliver. Correct. So I don't think that there is a winner this way or that way, right. But I think if customers are able to find a sweet spot for themselves, maybe the hybrids will have a play.
Yes, and it's quite evident from Tata Motors' perspective where you're placing a bet on, because you have gone
yes.
record saying that you are straight away focusing on what the eventual future is. Yes, Sumeet?
Yeah, maybe just to touch upon that question. So I think it's going to be how much of a bang for the buck will these efforts lead a particular OEM into getting. I mean, if your strategic objective is to lead to your net zero rather quickly, you would obviously not start a program which is going to run for the next 5 years, which is not going to give you that bang for the buck in reducing your carbon footprint. Therefore, the strategy of what your own carbon neutrality plans would be for your own OEMs would determine whether you'd want to go for hybrids or not.
You would like to add anything, Dr. Saravanan, quickly? Last word from you.
I think there was a question about hydrogen being breakthrough. In my view, there is no breakthrough technologies in the future. Every technology will have its place. So I think there's no such breakthrough, whether it's a fuel cell or a hybrid or hydrogen. Everything probably has a place, including hybrids. There are probably applications. We can argue whether it's a medium term or long term. There are probably applications where it makes sense. Even in some cases, for an OEM to meet CAFE norms, hybridization is one easy route. There are people who argue that hybrid is the right way from an overall environmental perspective. When you look at how much of lithium you would need from that perspective, I think so. Therefore, there is no clear answer. It is what your perspective is. You can argue EV is dirty. I can argue EV is clean. You can argue hydrogen is dirty. I can argue it is clean. So I think it is not about what the argument is. It's about saying what makes sense for us in the current context. What fuel is available, at what time, what does the customer prefer, how much does it save the environment? I think these are very, very complex questions. So therefore, there's no real answer. You have to evolve a strategy that depends on what the market wants. I think that's with that, I think I will end my,
no real answer, and as they say, no silver bullet when it comes to technology, but what is absolutely clear, that it will be a basket of technologies for sure, and that basket will be bigger than what it is today. I'm sorry we have run out of time, but we can always, of course, catch the panelists offline. Yes, and what is also quite clear, evident from the comments made by the esteemed panelists is that, yes, one of the questions which is the back of my mind for almost all of us is the future of the internal combustion engine. And as has been very clearly said, that it's not going away anytime soon, even not till the end of this decade, because that's the timeline we are looking at when it comes to this discussion. So those who are focusing on, who have an interest in ICE technologies and working on developing that further, can continue their efforts, while also perhaps looking, explore to expand to efforts to other areas of powertrain technology as well. So on that note, and gentlemen, Mr. Petkar, Dr. Saravanan, Sumeet, Praveen, thank you very much for sparing your time for this very interesting, engaging, insightful discussion. Always a pleasure to be a moderator, and also, such sessions also serve as a great learning experience for me. So thank you once again.